Hello, in this session we'll continue the discussion on life annuities. As you would imagine, we will now do the discrete life annuity. We already did the continuous, so same logic that we did for the insurance benefit. Now we will follow the continuous case with the discrete case with like the life annuity that's not payable continuously but rather paid at the beginning of the year. So we'll just wanted maybe like a quick review of the concept that we looked at in interest theory. Recall that in interest theory that you have an annuity due. Annuity. We call it annuity due. And annuity due, the word due, it tells us that payment at start of the year. Because there is another concept called annuity immediate. It's at the end of the year, but annuity due is at the payment is made at the beginning of the year. In the interest theory case, the certain case, we looked at it. It's a angle n, and instead it's not the continuous, but we'll use the two dots to say that it's due at the beginning of the year. So this one will give us a payment, let's say 0, 1, 2, payment at the beginning of the year. And the last term at n will have 0. But remember that this is n and this is n. Right? Because it's at the beginning of the year, and in interest theory we looked at this one is equal to 1 e minus v to n, right? This n, the same n here, even it's 0, but v to n divided by d. And what is d? You need to remember d is equal to I over 1 plus I. If you can't remember, you need to go to the review session of interest theory at the beginning of this course. I started with review of probability and review of interest theory. So you need to make sure that you understand these concepts. Because now we're going to take it to the next stage, moving from interest theory into actuarial present value. So this is the present value of this series. It's this one. For actuarial value, actuarial present value, we need now to incorporate the probability of death, right? Or probability of, like contingent on life. So how we'll do it, just also we recall the k function of x. We said this occurs like if this is equal k, it tells us like this. We need to recall this one, recall this concept that the coordinate life, that death, like let's say this is x plus k, x plus k plus 1. If this is k, then death happens between k and k plus 1, right? So we need to remember this k, it means surviving to k, and death occurs in this period. Just to remember. So now if we move from, this is the present value, incorporating this one, so this is the present value, and now actuarial present value. To move from the annuity certain, we need to take the new notation for this one. It's, as you would expect, A for annuity, two dots to say that the payment is paid at the beginning of the year, evaluated at age x, right? So to move from here to here, we need to take the expected value of A angle n. So if you like visualize this one, it gives us $1 at the beginning of the year, but conditional on surviving. So we need to make sure that it's conditional on surviving. Let's say visualize it. So you have x plus 1, x plus 2, here x, all the way to the end. So here it gives us $1 here, $1 here, $1 here, and keeps going, right? So, and now we need to discount this back on conditional. conditional on life. So if you would think of ax, there are several ways how to compute this one. The first one, let's take the let's take a few cases. If k is 0, so if k is 0, like this is the 0 here, 1, k, 2. If k is 0, what or death occurs between, remember what is, if k is 0, death occurs between 0 and 0 plus 1. So death happens here. Then if k is 0, the individual will get a 0, will get a 1, which is 1, right? If 0, the payment will get this $1. What if k is 1? Now the death occurs here. So now the individual will get this one and this one, right? So this will be A2, which is V plus, which is 1 plus V to 1, right? Now if k is 2, now k is 2, so the individual survived to here, and death occurs between k plus 2 and k plus 3. Now the individual will get this $1, will get this $1, and will get this $1. So we'll get the 3 of them. 1 plus V2 plus V3, right? So now we need the probability of this one, probability of this one, probability of this one. If we add the probability here, and let's generalize it. If k equals any value of k equals n, this will be a. See here too, you add 1, so n plus 1, 1 plus v2 2 v3. Last one, if you last one will be vn. Sorry, I made a mistake here. This one should be 1. This one should be 2. If you see that pattern here, you see 1, v0, 2, 1, and v1. The last term will be like kind of vn minus 1, right? Sorry, vn. Because here you have a plus 1. And this n will be with this one. This 2 here is like 2, 1, 1, right? Now to calculate the probability, to find the value of this one, we need to calculate the probability of each term. The probability of the green one is death occurs in the first year. This is x1, right? Now to get this one, so death happens here, surviving to here, dying here. So it will be px, then qx plus 1, right? Oh, sorry, maybe I need to write, maybe I'll use different color here. Let me use for everyone its color. This one is a qx, because death happens in the first year. Here surviving the first year, and death happen in the next year. Now for the third term here, you need to survive 2 years, 2px, and then death happens 2, right? And for this one to get this one, you need to survive to, like similar to here, you need to survive to n px, right? Because if you would think about this one here, you need to survive to here, right? and then by death happens on x plus n on this here. I survive here and death happens here. And the actuarial present value, which is you add them up, or we give it this term, right? This is the term we give it. The expected value is multiplication of the present value with its probability. You sum, right? You need to sum all of those. Like you remember from k equals 0, we start from k equals 0 all the way to infinity, because we continue all the way to infinity, and we sum from all the way to infinity, and then we get q k plus 1. Remember here what we do, 1, it's with 0, then we add 1 and multiplied by px and qx plus k. So you need to sum everything here. This is one way to compute it. This is one way to compute it. This is one way to compute it, right? I just wanted to make sure I give you the right thing. Yeah, correct. Alternative way, now ax, you can think about it alternatively, is you say, let me put it this way. You say I'll get 1, I get 1. So the ax, you can just simply add 1 plus v, and to get this v you need to survive px. Then v2, to get x plus 2 you need to survive. So you get what you when you survive, 2px. Right? You can summarize it also, ax v to k, again k from k0 to infinity, vk plus 1, actually vk multiplied by pxk. Right? That's an alternative way to do it, right? It's an alternative way to do it. This can be also written as summation from k equals 0 to infinity nex, same thing. Sorry, k. Right. So all of them, they give you the same notation. We'll see how we do that in calculation. But the only difference, so those are important. So this is one way and alternative way. Just the only thing you need to be careful about, if this one does not work for second moment. So if you want to calculate the second moment, don't use this formulation. You have to use this one. And how you will calculate the second moment? You raise this one to 2. Right? You raise the value to 2. Or in your table here, the one we created here, you keep the probability, but here the one you raise it to 2. This 1 plus v, you raise it to 2. This to 2, and you multiply this. But you cannot use any of these formulas here. It's very important to keep this in our mind. There is an alternative way, third way, alternatively. So there is an alternative way. Again, what we are trying to do is to calculate the actuarial present value, which is ax. There is an alternative way, which is a very good way, is 1 minus ax. This is discrete, there is no continuous case. And be careful here, because divided not by I or delta, it's divided by d. And d, always remember, is I plus 1 plus I. Usually this one is very, very common. You need to keep this one handy, right? So all these formulation, and this one is also important. Sometimes, you know, you have variable of benefits. You can compute it directly. Let's take one example on using this relationship, and then you see how we can get the same answer with this relationship. Let's take one example. Want you to remember that we to recall from when we talked about insurance benefit. We looked at this example. We looked at this example that you have, if you remember, we said we have like a cohort of 90 years old. This is age, and then this is the cohort, and the cohort 90, we followed a cohort of 90, 92, 93, 94. We followed a cohort of 1000. Those who survived to age 91, actually 800. Those who survived to age 92, 500. This example we took it before. Then 100, and then 0. We already calculated and go back to your notes. We already calculated A90 to be 0.8904. And this is already calculated it. Now we now find A at the beginning of the year for 90. So we need to find A90, the life annuity at age 90. So method 1, and always use the easiest one. The easiest one is A90 should be 1 minus A90 divided by D. And that example gave us I think it was 5%. Yeah, 5%. Right. So if I is 5%, remember D will be 5% divided by 105. Right. So this one then A90. Sorry. Let's write it here. It's simple. 1 minus 0.8904 divided, what is D? Is 0.5 divided by 105. We use the calculator quickly. I got it to be A90 to be 23016. Let's keep it because we're gonna use another method. Now let's use method 2. Method 2. Let's go back here. Maybe I can calculate it here. Let's do method 2 here. Now A90. The easiest way to calculate it is, now let's go back to these formulas. You can calculate it this one, but this one you need to calculate so many terms. Or calculate this one. I'm gonna use directly this one. So now we first payment here, the life annuity to give you 1, 1, 1, 1, and 1 here. So for if you survive, right? If you survive, you get, but actually nobody survives. So this one, nobody will claim it, but let's see. So now the first term, 1, you don't need anything, you get it, right? Because for sure you will survive age 0. So really, you get it, right? The first term is 1. Now let's look at the second term. How are you gonna get the second benefit here? Second benefit, you get it. Firstly, you need to get the discounted value of it, which is V. and multiply it by probability. You need to survive to get it. You know, it's life annuity. It's like pension. You get the pension if you survive. So to get this, you need to survive to P90. Same logic here. The second payment here, to get this one, you need to survive 2 years. So you get V2 to P90 plus V3 3P90 plus V4 4P90. Right, so 1, 2, 3, 4, 5. I mean, yeah, like you see. And then if this one we don't get it, we're gonna multiply it by 0 because no one's survived. But let's write it there. So let's now compute it again. 1 plus V. What is P90? V to survive here. Oh, this is 800 actually. 800 divided by 1000, right? Which is 0.8 plus. Let me. V2 multiplied by 2P90. You need to survive 2 years for 90. To survive 2 years is 500 divided by 1000 is 0.5. Then V3, maybe I can put parentheses here. To survive this, to claim this one, the third one, those probability of surviving is 100 divided by 1000, which is 10%. And to get the last term, which is V4, 0. Nobody survived 4 years, or to the beginning of the 5th year. Now, if you compute this one, it must give you the same answer. It must give you 2.30. What was it? 16. If little discrepancy, it means because we rounded up, right? So it must give you the same answer, but just remember how we calculated it. It's this way, right? We calculated each one. To get it, you need to survive to that year. There is a third method here. You can calculate it simply creating this table. You calculate it's what's A1, A2, A angle 3, A angle 4, and then calculate these probabilities. And then multiply them and add them up. But that will take us longer time. So those two methods are very good. Now let's take another term here. So we did method 2. Now let's take n-year temporary life. Another concept here. N-year temporary life annuity. And this is, we are discrete. Let me make sure that I put discrete. So one by one, we have n-year temporary, so it's for a period, and life annuity. So life annuity, start with life. Let's translate it. Let's start with this one. Life annuity. It means we're looking at a discrete. It means we need 2 dots. You know what? Let me use different colors so we can see how I do it. For the life annuity is A, right? Now it's discrete, and it's because it's life, then we give it X, right? Because it's it's life. If it's certainty, we don't give it X, right? Now discrete, it means we need to give it 2 dots. And n-year temporary, it means only for 2 years, for n years, sorry. You need to recognize, similar to continuous case, there is no one here. There is no one here, similar to continuous case. As the same thing we did for this one, we don't need to do it all the way to the end. We stop here, right? We compute this term. So instead of having continuous here for the n term, this one needs to go to n. Right? All you need to do is to stop it at n, and the last term we need to add another term to it, because what if you survive? Then n, you know what? Let me do it here separately. This one now, similar to that one, exactly what we did for that one, similar exactly to that one. You have a k plus 1, right? Will follow exactly what we did here, but there is an additional term. There is an additional term. Let me add it here. So k plus 1 from 0 to n, from k equals 0 to n. Exactly what I did before. Then you add k p x, and then you add q x plus k. This is not enough. We need to add 10. So this gives you an annuity for every year if death occurs, if every year, in every year, similar to what we did here. If death occurs here, here, but what if k is greater than n? That's where we need another term. If death does not happen in n period, the individual will end up getting the last term of the annuity, which is if death does not happen, which is npx, surviving x, then the individual will get last term of this one, which is sorry, I didn't write it here, but it's okay. The last term will be a n. So if like those, if death happens before, but this is if the like the individual survives that n period, will still get this one, right? We'll get those life annuity. This is one way to do it, but this is not the most efficient way. The other most efficient way is to write a x(n) is to write simple, similar to here, but instead of, you know, you have 1 plus v. To get the v, you need to survive, similar to what we did here. Similar to what we did here, but you stop it at n, right? So this one, you have v to survive px plus v2 to px plus v3 3px. The last term, we need to be careful about the last term. The last term, we need to be very careful, because this is now your x, or 0 1 x plus 1. So here you get 1, here you get 1, so it becomes v. Now x plus 2, you get another one, v. Now the last one here at x plus n, you get 0, right? So you need to be careful about this one, because the last, it's paid at the beginning of the year, not at the end of the year. So the last one will be v, and last one will be here, which is now k plus, will be n minus 1, and px to survive to n minus 1, right? And that's the last term. But usually, even if it looks confusing this way, it's usually when you do it, like you do a calculation, it's easier. Or if you do calculation, it's easier because you stop at that moment. Maybe we should take one example here. It helps us to understand it quickly. But before doing this, there is also, you can write it this way. And here you need to be careful in this one. This can be, you know, where many students make lots of mistakes here. And the reason I say many students make mistakes here, you need to recognize that there is no 1 here. You don't see 1 here. So this one here, similar to what we did in continuous case here, this will be ax So sometimes, you know, you put the first term and you forget about the second one. We need to be careful here. But let's take one example here. Or instead of taking new example, let's go back to the same example we did here. Now we calculated this one. Now let's calculate a 90 for 2 years. Let me write it here. So what if you wanted for the same example of 90 for 2 years? How we calculate this one? Simple. You do it for 2 years. 0, 90, 91. So you need two of them, $2. You cannot get more than $2. So 92, because at the beginning of the year you already got the dollar. You don't get anything here, right? So now we calculate this one is 1 plus V. To get the $1 here, you need to survive this year. So P90, right? Or if you go back to our calculation here, you calculate these two terms. So you need to be careful here. You have 2, you stop at n-1. You'd stop at n-1. You see why we stop at n-1? Or you get the first dollar and the second dollar, because you need to do it for 2 terms. And this one plus P90, P90, what's P90? 800 divided by 1000 to survive to here to get the 0.8. Here 0.8 divided by 105, we add 1 to it, is 1.762. Now let's take another concept here. Let's take another concept. Now let's take another concept here is the discrete. So we need to look at discrete case. And then we need to have n year, then deferred life annuity. Let's translate this into actuarial notation. Let's do that. To translate this into actuarial notation, let's start with the first one. The first one is life annuity. The red one is here. Life annuity, we know this. It's A. And because it's life annuity, there is X. It's not certain. If it's certain, there is no need for X. We just put an angle or whatever. Now, it tells us it's due. It's discrete, right? It's due. So at the beginning of the year. Let me write different color so you know everyone which one. Now it tells us it's n year deferred. N year deferred. Remember how we defer things? We add this little bar here, and this tells us deferred for n years, right? So in other words, you can write it n ax, right? So what is this? This is simple. We did it already in the continuous case. It's simple, right? This will start only after the deferred period. So this one can be written in many ways. Let's say x plus 1. So it starts here. So we're going to get 1 here, x plus n plus 1, another 1 here. So now we discount them back. So the first dollar will be V, right, n, and you need to multiply it, you need to survive to x plus n, so you need to survive npx. then v n plus 1, and then n plus 1. Sorry, to get this one, you need to survive it. Yeah, and then, sorry, yeah, n plus 1 px, and then you keep going, n plus 2 px, you keep going. But this can also be written as nax. This can be also written, instead of everyone bring it back, you can think about it as nex, then p, then ax plus 1. So simply what we're saying here, you get ax plus 1 here, and the whole thing you bring it back here. How you bring it back? You need the actuarial term, right? So either one or of these can work, right? Simple. It's actually, you don't need to memorize. It's just like if you know the terms, you quickly can translate what is the question, and then you can compute directly. Let's go back to our friend, the example here. We calculated this one. What if we want to calculate a question? Find, now for our question, for previous question, find 2a90. Now let's go back to A290. And let's calculate it somewhere here. We don't need this. So now we need to calculate A290. Simple. So we take from 90, we are here, so we need the first dollar is here. So how we get this one? We have $1 v to 2, you bring it 2, and to get it you need to survive 2px. Then the second dollar v3, 3px, and then plus 0, because nobody survived after this, right? So v2 2px, v2 to survive 2px is you take 500 divided by 1000, 0.5 plus 100 plus v3, because it's deferred, you take it back, you need the probability is 10, right? And this is just to say that this is the last, these two terms. This one is 0, we don't need it. So now this is these two terms. If you calculate them, 1.05 raised to 2, sorry, 1.05 raised to negative 2, because it's v, multiplied by 0.5 plus 1.05 raised to minus 3 sorry, 1.05 raised to minus 3 multiplied by 0.1 plus this, you will get 0.5 I hope I got it correctly. Yeah, that's correct. So wanted now to go, we got this one, right? Now let's go back to here. Now let's look at this you have x plus 2, x plus n, and continue here. So just similar to what we did in the continuous in the discrete case. If you have ax give you keep giving you all the way. Now what if you have ax plus n here? This will give you 1 1, will give you maybe in green 1 1 1 1 1, and this is evaluated here. And what if you have in red here ax n? This will give you 1 1 1 1. Last here will give you 0. Now if you combine these, the red and the green, if you combine the red and the green, so the red and green, if you combine them, ax n, right, the series of payment, the temporary, you add to it the green, which is ax plus n. You see 1 1 1, it's like the blue, it's ax, similar to what we did in the past. The only thing that this is evaluated here, where the rest is evaluated at x, so this one needs to be nex. This is a very, very important relationship. Very, very important relationship. And if you go back to our example here, what you can see in our example, like let's say, you can verify it in the same example for the previous example. Remember that this nex, this can be written also in qx for the whole thing here, right? For previous example, we calculated ax is, I think, 2302. Sorry, for the 90. Then we calculated also 90 for 2 to be 1.7619. We calculated 2 q90, calculated it to be also 0.54. I just calculated a second ago, right? This one is 1.76. And this one is 0.5399 or 54, and this one 23016. So we already just summarize them for you here. Yeah, we summarize them here. Now let's verify. So let's organize them. A90, is it equal to, for 2 years plus 2, oh, this is not the Q90, sorry. If you put this point, oh sorry, here 1.7619, it should be equal. Add to it 0.4, should give you 2.302. If there is little error, it means because of calculation error. I will verify myself, and I hope you can also verify yourself. Correct. It's there is 1.9, which is exactly the same thing, right? So this is very important relationship. We need to keep it in our mind. Lots of questions can come on this relationship. Many questions can happen on this relationship. It's very important to look at this. Now let's take one example. Because I already, this is an actuarial, previous actuarial exam. So just let's look at real questions from the Society of Actuaries exams. So this one I got it from Society of Actuaries. It's one of the questions that one time it was asked. So let's look at it. Let's look at this question here. So we have somebody age 40. Won $10,000, and this is actuarial lottery that can be received. The offer the actuarial equivalent of option of receiving an annual payment of K at the beginning of each year. So K at the beginning of each year, guaranteed for 10 years. Guaranteed for 10 years. So at the beginning of the year. So this is guaranteed. And then after that, will continue forever. After that, the same amount of K. So here K. But this one is here life annuity. Here is life annuity. So the question calculate the value of K that will make it equivalent. So let's write it. There is a specific notation for this one. There is a specific notation for this one, for the guaranteed. So the guaranteed in actuarial science, just to know how we solve this question here, when situation that you have guaranteed benefit and you have life annuity. This one can be written this way: A. This is at the beginning of the year, right? X, similar to what we did in the continuous case, and N, because it's guaranteed, there is another bar here, right? And this is like the guaranteed, the similar one we did in the continuous case. But the question here is, this is K multiplied by this one is given to us to be 10,000 because there is amount K, right? And this is the one that has K guarantee payment of K. So if you write this one, we have the K, right? And then let's look at what is given here. It's guaranteed for the first 10 years. So guaranteed, it's certainty at the beginning of the year for 10 years. It's for certainty, we'll get this amount of money for certainty. Plus, from year 50, you will be expected to get or evaluated at time 40, deferred. You know what? Let's write it this way. It's easier. At age 50, you're gonna get this amount, this of insurance with multiplied by K, right? But because we evaluating it at time 40 and the actuarial present value is 10,000 because they are equivalent, then here we need to get it 10EX, right? So because they are, and our X here is 40, right? Because we are evaluating at time 40, right? So now we need to find K. The question here tells us to find K. Okay. Let's find K. Once you reach this point, once you formulate it this way, then you take one step by one step. So firstly, we need the interest here, or the interest. What is the interest here? I is 4%, so we need 5%. So it's 1 minus V to 10 divided by D. And remember what, because this is at the beginning of the year, D is I over 1 plus I. If you use your calculator, so if you use our calculator for this one, I got it to be 8.43533, right? So now this one is done. Now we need 10 E40. We take term by term. Or let's take A50 first. A50. How we calculate this one? Let's see what we have. Let's see what we have to calculate. We need to calculate one by one. Let's see. For A50 we are given A40, which is good. Right, which is good because it's 1 minus A50 divided by D. What is A50? 0.35. 1 minus 0.35 divided by I of 0.4104. If you do that, I mean, you can do it quickly. 1 minus 0.35 divided by 0.4 multiplied by 104. So we got 16.9. So now we got this one. Now the last one is 10E40. Let's see how we can compute 10E40. Now the last one is we need to compute 10E40. Let's see what we have to how we can calculate 10E40. 10E40, we are given this. Yeah, I mean, we can rearrange these guys. So if you write A, let's arrange this one. If you write A40 is equal to A40 for 10 years, get this one plus, right? A plus, now we can calculate A50, but we need 10E40, right? Because you have 40, 50. So you bring them to evaluate back, it should give you like this. A plus this will give you the whole annuity, the A40. Right? So now if you calculate this A40, it's given to you by 0.3. This one is given to you by 0.9 plus 10E40 multiply by A50 is 0.35. Then 0.3 minus 0.09 divided by 0.35. Then this one if you solve it. So we got all the pieces here. Now all you need to do is you plug in. So now 10,000 is equal to K A10, which you already calculated this, 8.43533. I need to erase this. A plus 0.6, we already calculated it, and A50 we calculated it to be 16.9. So now we solve for K. So now we have 0.6 multiplied by 16.9. We add to it 8.43533. Then you flip it over, multiply by 10,000. Then the amount will be K to make it actuarial equivalent. Right, so this, a good question. In questions like this, you should expect, like questions like this that requires you to have multiple identities in whether you're writing actuarial exams or our exams in this course. All right, I think we covered a lot of material for today. Thank you.